Okay, so today what we're going to do is we're going to work with graphing the sine and cosine functions. And last time we worked with defining the trigonometric functions, and what we did is we defined them on the unit circle. So on the unit circle, given an angle, and if the angle is in radians, you can equivalently take it to be the arc length, as we saw. We were able to find the x and y coordinates of the circle, and from there we could write down all our trigonometric functions. Okay, so just to recap, and we're going to use this information to basically plot our functions. If we have t, and we're going to say t is in radians, or equivalent, you can think of it as arc length on the unit circle, because if you're dealing with the unit circle, the arc length and the angle in radians are going to be equivalent. So I have t, x, and y, and what I'm going to do is I am going to write my angles down over here, which the first one's going to be pi divided by 6. The next one is going to be pi divided by 4. The next one is going to be pi divided by 3, right? 30, 45, 60. And we have pi divided by 2, which is the same as 90 degrees. And then we keep going, just 2 pi divided by 3, 3 pi over 4, 5 pi over 6, and let's see, and we'll just have pi degrees. And then notice this is a multiple of 3 pi over 4, it's a multiple of 5 over 6, pi over 3, what we were doing at the end of class last time. Now the x value is, remember, the x coordinate tells us the value of the cosine, and the y coordinate tells us the value of the sine function. Okay, so let me go ahead and fill these in. And just remember, if we're at 30 degrees, I'm sorry, we forgot to start with the most obvious one, which is 0, right? Okay. So if we're at 0 radians, or 0 arc length, then the x-coordinate is 1, the y-coordinate is 0. If we're at 30 degrees, the x-coordinate is, remember, the square root of 3 over 2. And the y-coordinate is 1/2. If we're at pi over 4 degrees, they're both square root of 2 over 2. And if we're at pi over 3 degrees, where the x-coordinate is 1/2, and this becomes square root of 3 over 2. Notice how going from 30 degrees and 60 degrees, the x and y's just switch values. At pi over 2, the x-coordinate is going to be 0 now, and the y-coordinate is going to be 1. At 2 pi over 3, we're going to have negative 1/2, right? Because now we're in the second quadrant, and we're going to have positive square root of 3 over 2. Notice how we've, now we're going back opposite direction. The next one is going to be negative square root of 2 over 2, and square root of 2 over 2. Sorry, that should be a 2 on bottom. And then 5 pi over 6 is going to be negative square root of 3 over 2. And it's going to be 1/2. And pi, we eventually reach pi, and if we're on the negative x-axis now, x is going to be negative 1, and y is going to be 0. So essentially, what we've done here is we've started out on the unit circle at 0 degrees over here. We started at 0 degrees. And we looked at the x and y coordinates going up to pi over 2. And again, notice that the x-coordinate here is 1, the y-coordinate here is 0. And we move around these points till we get to pi over 2 radians, or pi over 2 degrees, over here. And notice that the y-coordinate here is 1, and the x-coordinate here is 0. And then we come down the other way till we get to 180, or pi radians. And at this point on the unit circle, you notice that the x-coordinate is negative 1, and the y-coordinate, or the height, is 0. All right. So we're just moving around the circle. And I could have filled in 30 degrees, 45 degrees, 60 degrees, but there's not a lot of room to write on the circle, so it's sufficient like this. And then what we can do is we can keep going, and we can start with t again over here, and we're going to do, to finish off, 7 pi over 6 is the next multiple pi over 6, and then we have 5 pi over 4, again this is going into the third quadrant. We have 4 pi divided by 3. We have 3 pi divided by 2. We have 5 pi divided by 3. We have 7 pi divided by 4. Oops, I'm going to run out of room here. And so I'm going to have to continue another line for those. And well, here's x and y. And the x value is going to be negative square root of 3 over 2. And it's going to be negative square root of 2 over 2. And this is going to be negative 1/2. And 0. And okay, what we've done now is we've basically gone from pi degrees, and we've gone back down to, did I make a mistake here? This should be square root of 3 over 2. 5 pi is square root of 2 over 2. Then 4 pi over 3 should be negative 1/2. Oops, I missed that. Then 3 pi over 2 is, of course, 0. Okay? And remember that this over here is going to be 3 pi over 2. And again, notice that the x-coordinate here is going to be 0, but the y-coordinate, or the height, is not 1, but negative 1 because we're going down. So this has coordinate x is 0, y is negative 1. Then 5 pi over 3, we're at a multiple of 60 degrees, and we're going to be at negative square root of 3 over 2. Sorry, that's negative square root of 3 over 2. Then 7 pi over 4 is going to be the square root of 2 divided by 2. And we just have a couple left over here. And it's going to be, say, t, x, and y again. And let's say we have 11 pi over 6. What's the 7 pi over 4? Okay, so we have 11 pi over 6. And again, I'm just taking multiples of pi over 6, pi over 3, pi over 4, just going around the unit circle. So we have 11 pi over 6, and 2 pi is the last one. And this is going to be, we're in the fourth quadrant now, so we're at a multiple of 30 degrees here. It's going to be, the x-coordinate is going to be square root of 3 over 2. The y-coordinate is going to be 1/2. And over here, we just, at 2 pi, we complete 360 degrees. And for this last point, so we're right on the positive x-axis again for the unit circle. So the x-coordinate is 1, the y-coordinate is 0. Okay, so we can use this information to plot sine of t and cosine of t, because the cosine of t is just equal to my x value. The sine of t is just equal to my y value, right? So I'll just plot that, and I hope the handwriting is not too bad. It's just a table to recall from last time. So we have the cosine of t is equal to my x. So if I have t, I want to know what the cosine of t is. I just look at x. And the sine of t is just equal to my y-coordinates. Okay? Okay. So next thing we're going to do is we're going to plot the sine function. So we're going to do the plot of the sine function. Okay, so we're going to plot sine of t, and the book might write it f of t equals sine t, but for now we'll just do that. And I'm going to note that this is an odd function, and I'll talk about that in a little bit. But this is an odd function for those of you familiar with that. And what the odd function means is that the sine of t, or sine of negative t, I should say, sine of negative, sorry, I'll just make this a t in here, and I'll say negative sine of t, so just, sorry about what I just said there, just, the negative sine of t is equal to sine of negative t. So essentially what it means is an odd function. Sine is an odd function. It means I can take the negative sign and pull it outside the parentheses, right? So if I have a negative pi over 4, I can pull out the parentheses, the negative sign, and make it a negative 1 times the sine of pi over 4. All right, that'll be useful in graphing these functions. Some functions are going to be even, some will be odd. And let's go ahead and graph this now. Okay, and to give you a basic idea of what it looks like, what I'm going to do is we start out 0 in the middle, and I'm going to do pi over 2, and I'm going to do pi, and I'm going to do 3 pi over 2, and I'm going to do 2 pi. Why did I use these? Because these are the easiest ones to plot, because it's where the functions are 0, 1, and negative 1. Make this one over here. This is negative 1. Okay. And over here, I'm going to write down negative pi over 2. I'm going to write down negative pi. I'm going to write down negative 3 pi over 2. And I'm going to write down negative 2 pi. Okay, so what I can do now is I can use this information to plot. And you're going to say, well, how can I use this information to plot? Well, basically, I'm going to use the table that I just had up here. Okay? Because on the table, I had the values for these. Because, first of all, I know that I'm talking about the sine, so I'm interested in the y value. So when t is 0, the sine function is 0, right? Which is right here. T is 0, the sine function is 0. Now, when next one I'm interested in is pi over 2. So when t is pi over 2, the sine function is 1. So it's going to be the value up here is the radians, number of radians is pi over 2. Then the value of the sine function is 1. And if I look on my chart again, I'm going to see that when the number of radians is pi, sine is 0 again. And if I look at my chart again, when I look up at 3 pi over 2 radians, the value of the sine function is negative 1, and then it comes all the way to 0 again. So it repeats its values every 2 pi radians, or 360 degrees. And when that's true, we call the function periodic if it repeats its values for some positive number. We'll talk about a little bit more of that in a little bit. But what I'm going to use here to the other way is I'm going to use the fact that it's an odd function. So at 0, it's 0. Well, what about negative pi